Good afternoon. This week we're going to do a lab with flow sensors. These are the Hall effect type. We have them that start at 3/4 of an inch. This is a 1-inch pipe size and all the way up to 2-inch pipe size. They're different flow rates. The highest is, looks like 10 to 200 liters per minute. This one, if it's on here, is 1 to 60 liters per minute. I think the 3/4 inch ones are about the same. These have either a turbine inside, you can see the turbine in there that's going to spin, or a paddle. Pretty hard to see the paddle in there, maybe you can see it. Paddle wheel. They create a Hall effect, or operate a Hall effect sensor, which is a switch, and the result of the switch and the turning turbine is going to be a square wave. If we can get the frequency of the square wave, we can get a relationship to how much fluid is going. So there's a direct relationship then between the hertz of the pulse coming from the sensor to the flow rate. What we've got set up using the fluid mechanics bench, we've got the water comes out of the pump and down this hose and comes around, comes through the first sensor right there. And it's going to go around a couple bends, goes through the second sensor, and then back and out of sight here briefly. The water comes in this discharge where there's a filter mechanism that's going to stop the spray anyway. A diffuser would be the right name for that. I'll turn this on. Now, but before we do that, we may recall we can measure the volume with this gauge on the back. Measure the volume and get the volume and the amount of time it takes to get to, say, 15 liters. And with that, we've got the volume flow rate. We can relate that to our LabVIEW program. And I'll turn this on. And away it goes. And we can see water filling up behind the dam here. If we look over at the LabVIEW program, over on the left you'll see the signal, and then this is the FFT, fast Fourier analysis. There seems to be a strong signal at 100 some hertz, as well as some noise out there. The tone gives us the strongest frequency, 110 or 111 hertz is what we're picking up right now. If we want to display a little better waveform, maybe we can do something like that. So I've got fewer samples, so it takes less time, and I can see the square wave anyway, kind of a choppy square wave. But once we get this going, we'll adjust the flow with the red valve here and do several different flow rates that suggest starting out full speed. And then you might recall we'll drop our valve down here, and that'll make a seal, and we watch the water come up. And with stopwatch in hand, and it comes up to 0. I don't know if you can see it or not, but you probably can barely see it. But start the watch, and then when it gets up to 15, we'll stop the watch, and we'll have 15 liters in so many seconds. I won't bore you with that. Okay, so we'll get several different flow rates, and we'll do a graph. Frequency on the x-axis, flow rate on the y-axis, do a regression analysis, and we'll determine the relationship between frequency and flow rate. I didn't use any Teflon tape. If anybody's bored and wants to tape some of these joints, well, I won't stop you, as long as it doesn't hold up the lab. If you look at the circuit here, the connections are not real complicated, and we'll figure that out when we get to the lab. Okay, see you soon.